Hello students, the next topic number 3 is canal losses and canal lining. So what is canal losses? When water flows continuously through a canal, losses do take place due to seepage, depercolation and evaporation. These losses are sometimes known as transmission losses. They should be properly accounted for, otherwise, lesser quantity of water will be available for cultivation at the tail end. That is at the end of the canal. So water losses in canals can be broadly classified under 3 heads. The first one is evaporation losses. The loss due to evaporation is generally a small percentage of the total loss in unlined canal. It hardly exceeds 1 to 2% of the total water entering into the canal. The evaporation losses depend upon climatic factors such as temperature, humidity, and wind velocity, canal factors such as water surface area, water depth, and velocity of flow. Maximum loss is there in summer months when temperatures are high and wind velocities are also high. Similarly, losses are maximum in unlined canals due to wider water surface area, shallow water depth, and low velocity. The average evaporation loss per day may vary between 4 mm to 10 mm. About lined and unlined canals we'll study in our upcoming units. Number 2, transpiration losses. The transpiration loss takes place through a lot of vegetation and weeds grow along the bank of canal. However, this forms an extremely small part of loss. In this picture you can see how water is lost in the canal. Number 3, seepage losses. Seepage losses constitute major portion of loss in an unlined canal. The seepage losses are due to absorption of water in the upper layer of soil below the canal bed and due to percolation of water into the river table. It thus raises the water table. If, however, water table is much lower, seepage losses are only due to absorption. Percolation losses are always much more than the absorption losses. Number 4, rate of water loss. Canal losses may be expressed in any one of the following methods. Number A, as cumex per million square meter of the wetted perimeter. B, as depth of water loss per day over the wetted perimeter. C, as the percentage of the canal discharge. D, as the percentage per kilometer length of the canal. And out of these 4 methods, the first method is the simplest. Next, canal lining. Canal linings are provided in canals to resist the flow of water through its beds and sides. This can be constructed using different materials such as compacted earth, cement, concrete, plastics, boulders, bricks, etc. Canal lining is an impermeable layer provided for the bed and sides of canal to improve the life and discharge capacity of canal. 60 to 80% of water lost through seepage in an unlined canal can be saved by construction of canal lining. Here I have shown you a picture of canal lining. Functions of canal lining. Considerable loss of water takes place due to seepage in earthen canals. So this loss is unavoidable unless the canal is lined. An irrigation canal is said to be lined when the bed and the sides of the canal cross-section are protected with impervious or fairly impervious material of sufficient strength. Thus, the main aim of lining the irrigation canals with impermeable material is to stop seepage, thereby saving valuable irrigation water. When canal is lined, considerable additional area can be commanded with the help of the saving resulted from lining the canals. Next, in continuation with functions of canal lining, when a canal is to be lined, the canal may be built to much smaller cross-section than an unlined one as there is practically no loss in the lined canals due to seepage. Condition of canal is also improved a lot and as a result it requires less maintenance. Lined canals check waterlogging in the areas adjoining the canals. Existing canals may also be lined, but then the construction work may interrupt the irrigation supplies. The canal in head ridge does not need lining. The obvious reason is that the seepage water is not lost totally. It goes back to the river. However, sometimes it may become necessary to line the canal in the head ridge also. Then the maintenance of the canal becomes an important problem as the water table in the head ridge is usually high and water behind the lining may create unstable conditions. The lining of existing or proposed irrigation canal is justified economically when the cost of the lining can be recovered from the increased monetary benefits in a reasonably short period. Advantages of canal lining. There are 6 advantages. The first one is seepage reduction. Number 2, prevention of waterlogging. Number 3, increase in commanded area. Number 4, increase in channel capacity. Number 5, less maintenance. And number 6, safety against floods. This is important. So number 1, seepage reduction. The main purpose behind the lining of canal is to reduce the seepage losses. In some soils, the seepage loss of water in unlined canal is about 25 to 50% of total water supply. The cost of canal lining is high, but it is justifiable for its efforts in saving of most of the water from seepage losses. Canal lining is not necessary if seepage losses are very small. Number 2, prevention of waterlogging. Waterlogging is caused due to phenomenal rise in water table due to uncontrolled seepage in an unlined canal. This seepage affects the surrounding groundwater table and makes the land unsuitable for irrigation. So this problem of waterlogging can be surely prevented by providing proper lining to the canal sites. Number 3, increase in commanded area. Commanded area is the area which is suitable for irrigation purpose. The water carrying capacity of lined canal is much higher than the unlined canal and hence more area can be irrigated using lined canals. Number 4, increase in channel capacity. Canal lining can also increase the channel capacity. The lined canal surface is generally smooth and allows water to flow with high velocity compared to unlined channel. Higher the velocity of flow, greater is the capacity of channel and hence channel capacity will increase by providing lining. On the other side, with this increase in capacity, channel dimensions can also be reducing to maintain the previous capacity of unlined canal, which saves the cost of the project. Number 5, less maintenance. Maintenance of lined canal is easier than unlined canals. Generally, there is a problem of silting in unlined canal, which removal requires huge expenditure, but in case of lined canals, because of high velocity of flow, the silt is easily carried away by the water. In case of unlined canals, there is a chance of growth of vegetation on the canal surface, but not in case of lined canals. The vegetation affects the velocity of flow and water carrying capacity of channel. Lined canal also prevents damage of canal surface due to rats or insects. And last one, safety against floods. A lined canal always withstands against floods, while unlined canal may not resist. And also there is a chance of occurring of breach, which damages the whole canal as well as surrounding areas or fields. But among the all concrete canal linings are good against floods or high velocity flows. So this is your assignment for lecture number 16. The question is, what are the possible causes of water losses in canals and what are the methods adopted for reducing such losses? The question is, I repeat it again, what are the possible causes of water losses in canal? What are the methods adopted for reducing such losses? So we'll watch a video. That's all for now, this class. Thank you.